This is another quick fire revision on environmental management. Now, in this particular aspect, we're going to be looking at chapter 7, which has to do with the atmosphere and human activities. So the first part of this topic is for us to look at the structure of the atmosphere. Structure of the atmosphere. So the atmosphere is divided into different layers, and basically for your syllabus, you need to know the characteristics of the four major layers of the atmosphere. And if you remember this acronym or this sentence called the silly monkey talks. So the silly monkey, the silly monkey talks. Now, this represent the various layers that you need to know in relation to your syllabus. D here represent the thermosphere, represent the thermosphere. The S is the stratosphere. The M is the mesosphere, and the T here is the troposphere. Sorry. Now, without wasting so much time, let's look at how these layers is arranged in relation to the distance from the Earth surface. Now, if you have the Earth surface as stipulated here, so if this is the Earth surface, which is majorly, let's say the crust. Now, the atmosphere is surrounding the Earth's crust. So within this, from the Earth crust up, before you move into space, there are different layers. Now, the first layer closest to the Earth is referred to as the troposphere, and the line separating the troposphere from the next layer, which is the stratosphere, is called the tropopause. Then the stratosphere, the line separating the stratosphere from the next layer is the stratopause. Then the line separating the mesosphere from the next layer is the mesopause. Then the thermosphere, exosphere, the exobase before you go to the outer space. So we're going to be looking at the characteristics of the atmosphere based on these four major layers and what actually happens at each of these layers. Now, in IGCSE exams, most of the times you'll be given a diagram of these individual layers and you just be expected to identify them. So once you remember the silly monkey talks, you should be able to know that the troposphere comes first before stratosphere, mesosphere, and then lastly you have the thermosphere. Now, let's look at the individual characteristics quickly. Remember, this is a quick fire revision. If you want to look at a detailed aspect of this, you need to watch the video on chapter 7, atmosphere and the environment. Now, the troposphere is the lowest and the thinnest layer and is approximately 16 kilometers at the equator and 8 kilometers at poles. Now, 90% of the atmospheric mass is found within the troposphere, and you find out that the temperature decreases with altitude. So, within the troposphere, the higher you go, the higher in the troposphere, the higher you go, the higher the cooler it becomes. The cooler it becomes. So, at the tropopause, which is the top of the troposphere, the temperature is approximately minus 50 degrees Celsius, and it is where weather occurs. So, at this point, that is where you can find cloud, and things like rainfall, snow, hail, thunderstorms occur within the troposphere. Then the boundary between the troposphere and the stratosphere, that's the line separating the two, is called the tropopause. Then from there we move to the stratosphere, which extends from where the troposphere ends, approximately 10 kilometers to 50 kilometers above the ground. It is less dense because there is less water vapor, and the temperature increases also with altitude, and there is almost no weather occurrence within the stratosphere. Now, in the stratosphere, the higher you go, the hotter it becomes. The hotter it becomes because temperature increases with altitude. Now, it contains high level of ozone, so the ozone have the ability to absorb sunlight. It absorbs sunlight, ultraviolet radiation from the sun, which is being used to warm that layer. That is why the higher you go within that layer, the hotter it becomes. And the upper boundary separating the stratosphere from the next layer, which is the mesosphere, is called the stratopause. Okay, features of the mesosphere. Now, in the mesosphere, the higher you go, the cooler it becomes also. So you find out that it extends for approximately it is 80 kilometers in height, and temperature decreases with altitude. So the higher you go, the cooler it becomes within this layer. And gases in this layer absorb ultraviolet radiation from the sun. Then lastly, we have the thermosphere, which is above the mesosphere and extend about 600 kilometers high, and the temperature increases with altitude. So within this layer, the higher you go, the cooler it becomes. Now, it's readily absorbs solar radiation, and temperature can go as high as 1500 degrees Celsius within the thermosphere. So within this layer, the higher you go, the cooler and the hotter it becomes. And lastly, it also is the area where radio waves are being reflected. Now, composition of the atmosphere, that will be the next aspect you need to know in relation to your syllabus. Um, Now, the atmosphere is a combination of gases but of different composition. Now, nitrogen accounts for 78% of the atmosphere, oxygen accounts for 21%, argon and other smaller gases occur for inert gases occur for 0.9% of the atmosphere. Now, you also have things like water vapor, and also nitrous oxide and the rest. But majorly, you need to know that 21%, 0.03 to 0.04% of carbon dioxide is also found within this layer. So please, you find out that the let's now look at the ozone layer within the atmosphere too. The ozone layer, also referred to as the ozone shield, remember it occur within, is found within the stratosphere. It's found within the stratosphere. It's a region in the stratosphere that absorbs most of the sun ultraviolet radiation. That is why within the stratosphere, the higher you go, the hotter it becomes. It contains high concentration of ozone, which is made up of 3 molecules of oxygen. Now, in relation to other part of the atmosphere, although still small in relation to other gases that are found within the atmosphere. So quickly, let's look at other aspect now that is related to this topic. First, let's look at this greenhouse gas effect, and this is the ozone layer. So quickly, you have the sun, and the ozone layer is made up of a combination of oxygen. So you have 3 oxygen molecules, and what it does is it helps to absorb electromagnetic radiation, ultraviolet radiation from the sun. So it reduces the ultraviolet radiation that reaches the earth surface. Now, the natural greenhouse effect. So you need to know how natural greenhouse effect works for you to be able to understand what enhanced greenhouse effect means. Now, you see, the greenhouse effect is a natural process that warms the Earth's surface. So it's a natural process that the electromagnetic radiation, the solar radiation from the sun, is needed in order for the Earth's surface to be warm. And this light that reaches the Earth's surface is needed for plants to photosynthesize to make their own food. So you find out that when the sun energy reaches the Earth atmosphere, some of it is reflected back to space and the rest is absorbed and re-radiated by greenhouse gases. So greenhouse gases within the atmosphere absorb some of this ultraviolet radiation, and then now be radiated it back to the earth's surface. So look at reflected, absorbed. Now, so you find out that greenhouse gases include things. Example of greenhouse gases are your water vapor, carbon dioxide, methane, nitrous oxide, even the ozone, and some artificial chemicals such as CFCs. I've seen questions where they will ask you to identify an example of a greenhouse gas. So any of this we actually go. Now, the absorbed energy warm the atmosphere and the surface of the earth, while the process maintain the earth temperature at around 33 degrees Celsius, warmer than it would otherwise be if allowing life to exist on earth. So you find out that if there is no natural greenhouse effect taking place, the earth might be too warm to sustain life. That is why the enhanced greenhouse effect is a process whereby the amount of greenhouse gases increase abnormally within the atmosphere, that most of the long wave radiation radiated back to space from the earth is being absorbed and not allowed to go back to the outer space. So it will now remain within the earth's surface and keep it extremely warm. Now, so moving forward, let's look at atmospheric pollution and its causes. So in this case, in atmospheric pollution and its causes, one major one your syllabus needed to look at is smog. So looking at smog, you find out that smog is formed from volatile organic compounds, and these are from either industrial processes such as vehicle emissions. Now, vehicles normally release gases into the atmosphere, so they release gases into the atmosphere, which normally will be used to which trap long wave radiation from the earth to warm that earth surface. So how is smog formed is very important you know this. Now, smog is usually a yellowish or a brackish fog formed mainly by a mixture of pollutant. These pollutants are these gases from industrial waste and vehicles emitted into the atmosphere, which consist of fine particles and ground level ozones. So they form a form of shield around the Earth's surface. So when sunlight and heat react with these gases, the fine particle in the atmosphere, then you find out that smog will now be formed. So it's smog act like an artificial shield or within the troposphere, within a particular area. Now, this smog is also enhanced by temperature inversion, in that these gases are supposed to move out and go far into the atmosphere, but this temperature inversion will now help to trap these gases within the troposphere, within an area, such that it will now become a particular hazard and affect that environment immensely. So you find out that temperature inversion is a situation whereby warm air mass does not rise, instead stay near the ground, and this does not rise because it is being trapped by this pollutant. Now, during situation of temperature inversion, if the wind is calm, smog may get trapped and remain over a place for many days. Now, there are lots of impact of smog. So if you're asking the exam, how is smog formed? Simple. Smog is formed from pollutants from industries or vehicle emissions. Now, once they get into the atmosphere and they react with sunlight and heat, you find out that a smog, which is like an artificial ozone layer, will now be formed. And this due to temperature inversion, you find out that the air, warm air within the Earth's surface, will not be able to go into space to condense to form rain, because they will now be trapped within the ground level by this smog. So, impact of smog. The question that they will ask you is, what is the impact of smog on human health? Which is straightforward. Because it's a form of air pollution, you should know that it can cause asthmatic attack, it can affect your bronchi, leading to bronchitis. It causes irritation to the eye and it reduces visibility. You will not be able to see properly. It leads to pulmonary diseases such as lungs cancer. So pulmonary disease such as lung cancer, it causes lung cancer, and it leads to low reduction, or it leads to reduction in vitamin D that prevent rickets. So it will not be. Now, acid rain, formation of acid rain. This is quite simple also. Now, acid rain is formed when fuel, when you burn fuel or during volcanic eruption from industries uses fuel, cars uses fuel. So all of them will now release sulfur dioxide or nitrous oxide to the atmosphere. Now these gases, sulfur dioxide, will now react with water to form what? Sulfuric acid. Now this sulfuric, to form sulfuric acid, while the water is condensing, so which is acidic, and it will now reduce the pH of the water, so it falls to the earth surface as what? Acid rain. So whether is it being nitrous oxide, we react with the same water to form nitric acid, to form nitric acid. So what you get now is when fuel burns, volcano erupts, sulfur dioxide, nitrous oxide release, this dissolve in what? The water vapor or in rain, falls as rain with low pH, which is now acidic. Well, what is the impact of acid rain? Normally it falls as it causes acidification of water body, and if water body is being acidified, then you find out that the fish population will decrease, so some fish will die. It leads to damage of crops and vegetation. It leads to damage of buildings also. So when you are trying to write a multiplier factor of this, when it leads to damage of vegetation, if vegetation is damaged, biodiversity will be lost. Biodiversity, biodiversity is lost, and once biodiversity is lost, you find out that vegetation habitat is lost, biodiversity is lost, so it can lead to extinction of certain species. So, ozone layer depletion. So, what are the actions of CFCs, which are conchlorocarbons? So, you see, quickly, uh, let's see, the ozone layer depletion is simply the wearing out, or it is the reduction of the amount of ozone in the stratosphere. So once the amount of ozone that is found in the stratosphere is being reduced, is referred to as ozone layer depletion. And what causes it? You see, ozone initially we said is made up of O3. So what will now make these three molecules of oxygen reduce or wear out or break down into smaller molecules will now cause a depletion in ozone. So let's look at the process involved. Now, one, CFCs are confluorocarbons and also greenhouse gases. Once they are released into the environment by industries, they raise into the stratosphere. So remember, we have the troposphere, then before the stratosphere. So these CFCs have the ability to move up about 10 kilometers, more than 10 kilometers, to move into the stratosphere. Now, once you get to the stratosphere, sunlight will now react with the CFCs to break it up to release chlorine. Remember, CFC since means conchlorocarbon. So there is chlorine, it means chlorofluorocarbon. So there is chlorine in it. So the sunlight radiation breaks this CFC to release chlorine, and the chlorine will now react with the ozone and destroy it. So more reaction causes more depletion. So more release of these greenhouse gases, especially CFCs, into the atmosphere, it will now lead to more depletion of the ozone layer, because these CFCs can be broken down by sunlight to release chlorine, and the chlorine will react with the ozone in order to deplect it. That's the ozone layer depletion. It's as simple as that. Now, what is the impact of ozone layer depletion? You see, once ozone layer is being depleted, there will be high rate of ultraviolet radiation reaching the earth. Remember, one major function of this ozone layer is to trap electromagnetic radiation, ultraviolet radiation, absorb it and refract it back to space. But if it is no longer there, that means there will be no absorption taking place, so it will be able to reach the earth's surface, and thereby the earth will be extremely warm, which can lead to skin cancer, causes cataracts, and it also destroy vegetation. So those are the major impact. Then next, let's look at enhanced greenhouse effect. Remember, we've looked at natural greenhouse effect. So let's look at how enhanced greenhouse effect works. Now, enhanced greenhouse effect happens when there is excess release of these greenhouse gases like carbon dioxide, water vapor, and methane into the atmosphere. Now, what it does is this is quite really simple and clear. Resume. Okay, sorry for that swift interruption. Let's just continue quickly. Sorry, greenhouse gas effect enhancement. So let me explain this with this. Let me see with this diagram to help to understand the concept better. Now, first we have the sun. On a normal day, the sun releases ultraviolet radiation to the Earth's surface. Now, as it releases ultraviolet radiation, it passes through um, layers of clouds within the troposphere. Now, what happens is this cloud have the ability to absorb some of this radiation, and once it's absorbed, it's able to reflect, bounce some back to outer space, and some will be able to pass through it and reach the Earth's surface. Now, once it reaches the Earth's surface, it will be used and absorbed by the Earth's surface. So, what is expected is this incoming radiation are referred to as shortwave radiation. So they are shortwave radiation as it reaches the Earth's surface. Now, this energy that is being absorbed by materials that are on the Earth's surface, both buildings, both vegetation, water, the soil, trees, are meant to be reflected. You see, they are meant to be reflected back to space. Now, in order to keep the earth temperature constant. Now, that is what happens in normal greenhouse effect. This radiation goes back to outer space without any interference. But what greenhouse effect now does is this methane, carbon dioxide, chlorofluorocarbon, sulfur fluorides, and nitrous oxide are gases that are now trapped inside the atmosphere. Now, as the earth and materials on the earth surface release this energy that from the ultraviolet radiation that it absorbs, that is reflected back to space, what happens is these gases will now trap them. The gases will absorb them, and some will be able to pass through back, while some will be reflected back to the Earth's surface. So instead of it all the percentage going out, some will now be reflected back to the Earth's surface, keeping the Earth extremely warm, because once it's reflected back, the next day more will be added to it. So this is what will now cause the enhanced greenhouse effect, that the earth temperature will now be extremely hot and leading to what? Things like global warming and climate change. So this is more like an explanation of it. So you can actually pause the video and read through this to give you a better explanation of what I just said. Where solar radiation from the sun reaches the Earth's atmosphere, some are reflected back into space. The rest is absorbed by land and ocean, heating the Earth. So at night, this absorbed heat is radiated back to space as long wave radiation. So you can read through it, you get the whole concept clearly. Now, what are the impact of greenhouse effect? They lead to climate change and global warming. So because the earth temperature is now warm, it will lead to melting of ice sheet and glaciers, and also permafrost. And this heating, this global warming will lead to sea level rise, which sea level rise can also lead to what? Flooding. And flooding can lead to loss of land, loss of vegetation, loss of habitat, and affect a whole lot of species. So that's just using multiplier effect to explain this concept. Now, lastly, it can also lead to forced migration because the temperature within that area is too hot. Climate change, people will tend to leave such an environment. So quickly, let's now look at the last part of this syllabus, which has to do with managing atmospheric pollution. How do you manage pollution from atmosphere? And some of the ways to manage atmospheric pollution is you reduce reduction of carbon footprint, reduce use of fossil fuel. All these will help to reduce greenhouse emission of greenhouse gases. They will reduce emission of greenhouse gases greenhouse gases through reduced use of fossil fuel, reduction of carbon footprint. You can use cars that have catalytic converters, efficient energy efficiency, carbon captures and storage. You come up with transport policies such as which will help to reduce the use of private cars. You should promote the use of public vehicles. You should come up with transport policies such as the use of electric cars, and the rest. So international agreement and policies on managing atmospheric pollution. CFCs, you should create gases that will replace CFCs, so chlorine will not be released to reduce the ozone layer. Get cars that uses catalytic, or machines that uses catalytic converters. Fuel gas desulfurization should take place, and taxation, you should increase taxes on people that uses most of this non-renewable energy that releases greenhouse gas into the atmosphere. Then you should come up with reforestation and afforestation, because trees uses this carbon dioxide, which is a greenhouse gas, for photosynthesis. So they help in that process in purifying the atmosphere. So lastly, what are the reasons why acid rain, global warming will affect everyone? So you should take note of this. I've seen it a lot in past papers. Why you find out that acid rain and global warming affect everyone. First, gases can be moved over long distance because the atmosphere is not a barrier. It doesn't have a barrier. So gases can be moved along over long distance, and wind move gases over this long distance, and gases produced in one country can affect other country. Now that's it about this atmosphere and its environment. If time permits, I will also do that of a quick revision on chapter 8 on human population. So good luck and in your exams tomorrow.